Okay, so today's lesson was on prime numbers, prime and composite numbers. Colby, you have this paper, so if you want to pause it right now and get these definitions down, that would be great. Brody, I think that you are supposed to be coming back tomorrow, so you'll have this whenever you return tomorrow. But this is going to be our lesson today, and now it's a little bit unusual. But we are going to look through the numbers 1 through 100, actually 0 through 100. Let me change that. I got it here. And talk about numbers that are prime, composite, or neither. Now, let me scroll down. Now, we talked about let's look at this. We know that factors are two numbers that are multiplied together. We know that multiples are like skip counting. They're the answers. A prime number is a whole number with exactly two factors. It only likes one and itself. Let me add that. Only likes 1 times itself. Let me make this. So you can tell that's a 1. There we go. All right. Only likes 1 and itself, 1 times itself. Now, a lot of times I like to use this to help me. Prime numbers are picky numbers. They only like 1 in themselves. They only have 1 factor pair, which means they have exactly 2 factors. Now, a composite number is all the other numbers. They are numbers that have more than 2 factors or more than 1 factor pair. So in learning about these prime and composite numbers, we are going to look at this chart right here. Okay, so what I'm going to do is I'm going to mark off the numbers that are composite, and I'm going to circle the numbers that are prime. Colby, you can do this with me since you have yours. So let's take a look. The first thing I want us to do is mark off 0 and 1, because 0 and 1 are actually neither. They are neither prime nor composite. To save time on recording this lesson, we'll discuss this whenever y'all get back to us in class, but just know 0 and 1 are neither prime nor composite. They do not follow the rules for either one, okay? So those two are my only ones that are neither, 0 and 1. Now, let's look through the rest of these. So let's think about my factors of 2. This is how I'll know if a number is prime or composite. My number 2 with my factors likes 1 times 2. 1 times 2 is the only factor pair that I have. It's the only factors that I have, 1 times 2. Now, since 2 only likes 1 times itself, it is a prime number. So I want to circle this 2 because it's prime. But here's the catch. My multiples of 2, like 4, 6, 8, 2 times 2, 2 times 3, 2 times 4, 2 times 5. So if I were to skip count and get all of my multiples of 2, guess what? All of my remaining or infinite multiples of 2, all of my multiples of 2, except for 2, are all composite because they all like the number 2. 2 will divide into it. Let's look at 4. I know 4 is composite because it likes 2 times 2. Doesn't matter what else. I know that 72 is composite because it likes 2 times C3, 36. It doesn't matter how many a number likes in addition to 1 in itself. And I say likes to make it relevant, to make it easy for you to understand. But it doesn't matter what factors a number has or how many they have. The only thing that matters is that it likes more than 1 in itself. So if it likes more than 1 in itself, it is a composite number. All of my even numbers, because all multiples of 2 are even, all of my even numbers except for 2 are all composite numbers because the number 2 will evenly divide them. So let's go through here and let's mark out all of my even numbers. Now, instead of putting an X, I'm just going to do one line so it does not take me as long. So I'm marking out all of my even numbers. And remember, I can mark out all of these even numbers because 2 will go into all of them. Since 2 goes into all of these, they cannot be prime because they like more than 1 in themselves. So I'm marking out all of my composite. All right. Continuing to mark out all of the even. Now, if you need to pause this while you mark them out, please do, but I'm going to continue on. So let's take a look at the number 3. So let's think of my factors of 3. 1 times 3 gives me 3. 2 won't work, and 3 is already up there, so that means I'm done. So guess what? 3 only likes 1 in itself, so it is prime. But all of my multiples of 3 after 3 times 1, 6, 9, 12, all of those need to be marked off because 3 will evenly divide into them. They like 3. They like more than 1 in themselves. So I need to mark off all of my multiples of 3. So I do 9, 15, 21, 27. These are all numbers that 3 can multiply and give me as multiples. If you, once we start getting higher, you're not going to know these, but you can use your trick. 3 plus 9 is 12, and 3 will go into 12, so 3 will go into 39. 4 plus 5 is 9. 3 will go into 9, so 45 is divisible by 3. 51 is divisible by 3 because 5 plus 1 is 6. 57 is divisible by 3. 63 is divisible by 3. 69 is divisible by 3. 75 is divisible by 3. 81 is divisible by 3. 87 is divisible by 3. 93 is divisible by 3. And 99 is divisible by 3. All right. So that's all of my multiples of 3. Now let's look at 5. What are my factors of 5? So the only numbers that will give me 5 are 1 times 5. 2 won't work, 3 won't work, 4 won't work, and 5 works, but it's already up there, so I'm done. So since this has exactly 2 factors, or exactly 1 factor pair, because there's 2 numbers in a pair, this is a prime number. But all of my multiples of 5 end in a 5 or a 0, so I need to mark them out because that means that they're composite. That means more than 1 in itself are factors. So I've already marked out my zeros over here because I had to mark out all of my even numbers. All of these are composite. Now I just have to go through and make sure that I've marked out all of my 5s. Okay? So 5 is done. Let's take a look at 7. What are my factors of 7? 1 and 7. So 7 is prime. Now, you may be thinking, oh, okay, Miss Moore, all of my odd numbers are prime. Well, a lot of them are, but a lot of them aren't. As you can see, 21 is composite, 51, 81. 2 is even, but it's composite. So just, sorry, 2 is even, but it is prime. So just be careful because there's no pattern that you can find or no tip or trick other than finding your factors of these numbers. So, as we were saying, 7 is prime. Now I need to mark out all of my multiples of 7. Now we have a lot of them marked out, but I need to mark out 49, 7 times 7. I need to mark out 77, and I need to mark out 91. Remember, there's no trick for 7s, you just have to divide it. All right, so now let's look at 11. Just double check and make sure that you marked out all of your multiples of 11, all of those doubles, and we did. And so now this should be all of my prime numbers left. There should be 25 of them, so let's double check. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25. All right, so these are all 25 of my prime numbers between 0 and 100. Remember, these little numbers right here are exceptions to the rule. 0 and 1 are neither. And remember, prime numbers they only have 2 factors or 1 factor pair. Composite numbers have more than one. Now, you are going to be able to use this on classwork and homework. I'm hoping to build up that muscle memory with your brain with looking at these and checking if they're right on your paper. You will not be allowed to use this on a daily grade or a test, though. So ultimately, you have to know how to use your factors to find out if a number is prime, composite, or neither. I am going to upload an additional video for y'all just to kind of help explain prime and composite more. But hopefully this will help you with your classwork for today. I miss y'all. Bye, guys.